Imagine opening a dashboard with thousands of rows, users, products, analytics, and every scroll or edit feels instant, no matter the data size or your device. Now picture achieving that lightning-fast performance without bloated third-party libraries, keeping your bundle size lean, your code maintainable, and your users delighted. If you've ever struggled with slow, laggy React tables, or faced the dilemma of whether to reach for a library or craft your own, this tutorial is for you. Today, you'll discover the secrets to supercharging table rendering in React by mastering PureComponent and functional components with React.memo, core tools that unlock near-instant updates even as your data grows. You'll learn exactly how React's rendering lifecycle works, why naive implementations can grind to a halt, and how smart memoization and shallow comparisons can reduce unnecessary renders by up to 90%. We'll dissect both class-based and modern functional approaches, revealing which is best for your project, how to avoid common pitfalls like unstable keys or prop drilling, and how to build tables that remain smooth and responsive without sacrificing control or flexibility. Understanding these optimization techniques isn't just about speed. It's about giving your users a seamless experience, making your codebase future-proof, and freeing yourself from heavy dependencies. You'll come away with practical skills you can apply to admin panels, analytics suites, CRMs, or any data-heavy UI, plus the confidence to tackle performance challenges head-on. If you're serious about building world-class React apps and want exclusive in-depth guides that keep you a step ahead, make sure you subscribe. Each tutorial is packed with real-world examples, actionable tips, and insights drawn from the latest best practices, so you can keep your front-end skills sharp and your apps at the top of their game. Imagine your React app as a busy post office. Every time a letter, in this case, a data update, arrives, the post office could choose to notify every single worker, or just the ones whose tasks actually changed. In React, this is the difference between naive and optimized rendering. Understanding React's rendering lifecycle is the gateway to mastering front-end performance. React maintains a virtual DOM, a lightweight copy of the real DOM. When you update state or props, React constructs a new virtual DOM and compares it to the previous one, identifying what truly changed. Only the differences are patched to the real DOM. However, this process isn't free. If you have a table with thousands of rows and a single cell changes, you want only that row or cell to update, not the entire table. The challenge is that in React's default behavior, a state or prop change at the top can trigger a re-render for the whole subtree, potentially causing every row and cell to rerun their rendering logic. This is where memoization, via PureComponent for classes or React.memo for function components, acts as a smart gatekeeper. Like an efficient postmaster, it checks, did the props or state for this row change since last time? If not, it skips the update. By leveraging PureComponent and React.memo, you ensure that only those components with changed inputs actually re-render, dramatically reducing computational overhead and boosting responsiveness, especially when rendering large tables. Consider two skilled carpenters. One uses classic hand tools, class-based components with PureComponent, while the other adopts modern power tools, functional components with React.memo. Both strive for efficiency, but their methods differ. PureComponent is a class-based React feature that overrides the default update mechanism by providing a shallow comparison of props and state. If nothing has changed, the component's render method isn't called. This is straightforward and requires minimal code. Simply extend PureComponent instead of component. However, PureComponent is limited by its shallow comparison. If your prop is an object or array that gets a new reference but identical content, PureComponent will still re-render. On the other hand, React.memo wraps functional components, achieving similar memoization by default. Its true power lies in flexibility. You can provide a custom comparison function to handle deep or selective checks, enabling more nuanced control over when a component should update. Additionally, functional components can leverage hooks, such as use callback and use memo, to stabilize props and avoid breaking memoization due to reference changes. This enables a more surgical approach to optimization, ideal for modern React development. Ultimately, while PureComponent and React.memo both offer significant performance gains in data-heavy UIs, React.memo paired with hooks offers greater flexibility, composability, and alignment with React's functional paradigm, making it the preferred approach for most new projects. This is the main application file that demonstrates side-by-side rendering of a large table using both PureComponent-based and functional React.memo component paradigms. It includes state management for toggling user status and memoizes the event handler to ensure stability of props for optimal memoization. This supporting file provides the PureComponent-based class implementation for the table, which maps each row to a PureComponent table row class. The key design is to leverage React's shallow prop state comparison to avoid unnecessary re-renders when each row's props remain unchanged. This file defines the PureComponent-based class for rendering a single row in the table. It receives the user object and a stable on-toggle active callback as props. The use of PureComponent ensures row rendering is skipped unless the props change by shallow comparison. This is the functional implementation of the table component. It renders rows using the memoized table row functional. The table itself is memoized with React.memo to prevent unnecessary re-renders when the props don't change. This file defines a functional memoized table row. It uses React.memo with a custom comparison function for strict control over re-rendering. The row only re-renders if the user object or the event handler reference actually changes. This is the data source for the table. It programmatically generates a large array of user objects for demonstration and performance testing. Each user object includes an ID, name, email, role, and active status. This is the main entry point for the React application. It uses React 18's Create Root API, ensuring optimal concurrent rendering capabilities. This test file uses React testing library to verify the functional table's row rendering and the correctness of the status toggle handler. It ensures that the table displays user data properly and that the event handlers receive the correct user ID. This configuration file specifies project dependencies, including React, React DOM, and test utilities. It ensures the correct environment for running, testing, and building the demo. The application loads, displaying the main header titled React Table Performance Demo, and a descriptive section explaining the purpose of the demo. Below, there are selectors allowing the choice of different table implementations and data sizes. A label marked Table Type is visible, offering options such as Class, PureComponent, Functional, React.memo, and Virtualized. Another label, Data Size, enables selection between various row counts, including a large dataset of 10,000 rows. A counter displays the number of table re-renders in real time. The data size is increased to 10,000 rows using the data size selector. The application processes and updates, now rendering a much larger table with the chosen number of rows. After a short pause for the rendering to complete, the table type is switched to the class, PureComponent, implementation using the table type selector. The interface responds by re-rendering the table using class-based components, and the re-render count updates to reflect this change. An animated indicator highlights when a render occurs, and the statistics for render count are observed to update accordingly. The demonstration proceeds to the main table area, which now displays thousands of rows. The view is scrolled down to reveal more rows further down the list. As the table is scrolled, the smoothness of rendering can be observed. The first visible status button showing either active or inactive for a user is hovered over and then clicked. The user's status toggles, and the corresponding button updates its color and label in real time. The table's re-render count is observed to increase only minimally, illustrating that only the affected row or component is updated, not the entire table, showcasing the optimization benefits of PureComponent. Next, the name column header is clicked to trigger sorting. The table sorts the rows by usernames, and the re-render count increases accordingly. The animation and statistics provide insight into the efficiency of the rendering process, as the table updates to reflect the sorted order. The table type is then switched to the functional React.memo version using the selector. The table re-renders, now utilizing functional components with memoization. The change is reflected in the re-render count and the animated render indicator. Again, a user's status button is hovered over and clicked, toggling the status between active and inactive. The UI updates instantly for that row, and the re-render statistics show that only the relevant row or component is re-rendered, similar to the PureComponent version, but using React.memo for optimization. Afterward, the registered column header is clicked to sort the table by registration date. The table updates, and the render count and statistics are updated in real time, illustrating the performance impact of sorting operations. The demonstration then transitions to the virtualized table implementation via the table type selector. The table now displays a scrollable container that only renders the visible subset of rows, making it especially efficient for very large datasets. The virtual table container is hovered over, and the mouse is used to scroll down through the virtualized list. As scrolling progresses, new rows are rendered into view, while off-screen rows are efficiently removed from the DOM. The fluidity of the scrolling and minimal resource usage demonstrate the power of manual virtualization, all without third-party libraries. Within the virtualized table, the fourth status button in the visible rows is hovered over and clicked, toggling that user's status. The row updates instantly, and only the visible portion of the table is affected by the re-render, as shown by the render statistics. The last login column header is then clicked to sort by the last login date, and the table updates the order of visible rows efficiently. To conclude, the Reset Data button is clicked, restoring the dataset to its original state. The table resets to the default view, and the render statistics update accordingly. Finally, the view scrolls smoothly down to the application footer, where a note is prominently displayed, emphasizing that no third-party libraries are used for table rendering or virtualization in this demonstration. The application remains responsive throughout, with all interactions, switching table types, toggling statuses, sorting columns, scrolling, and resetting data, executed seamlessly and with minimal unnecessary re-rendering, effectively illustrating the practical performance gains of PureComponent, React.memo, and manual virtualization in real-world React table implementations. You've just unlocked the essentials of React table performance, mastering the difference between PureComponent and functional components with React.memo, all without the crutch of third-party libraries. With these strategies, you'll notice smoother scrolling, snappier updates, and interfaces that handle thousands of rows seamlessly. Imagine your dashboards and admin panels staying lightning fast, even as your data grows. Now is the perfect time to put these insights to work. Refactor an old table, profile your app, or try out row-level memoization in your next project. If you're eager to keep building React skills that make a real impact, where every tip is proven, practical, and ready for production, subscribe now. This channel is dedicated to giving you the clarity and confidence to ship high-performance apps faster. Your next breakthrough is just a click away.